So right now we're gonna have like the boring part of me explaining a bit the challenge and the exciting part of announcing the winners. So the people that actually won the challenge and all our special awards. Of course, first is the boring part, so you're compelled to listen to it before we actually announce the awards. But I'm gonna try and be fairly quick. Thank you. Can you hear me? Can you hear me? Can you hear me? Yeah. This is most for posterity, as most people here, as most people that I see here have been intimately related to this challenge. But some of the people that are joining us now may not know exactly what we've been doing. And so this presentation serves both as a recap of previous episodes, a bit of survey of what we learned, and of course, celebrating all the people participating in this and awarding the winners of our several categories. So EvalRS was designed to be, and I think it happened to be, the first of its kind data challenge in the recommender space. Models are asked not to be just accurate, but also fair and robust. We kind of build it based on 3 philosophical principles. One, which I think has been extraordinarily explained in our first keynote, like point-wise metrics are not enough. So if you just keep on talking about accuracy, just a tiny percentage of what the model is going to do in real life, and we want you to operationalize the desiderata, what you want the system to do in code. Second, we are very open. Everything about this challenge is open source, and a lot of people actually contributed already to the GitHub repository. All the people that made a submission were by design asked to push their submission to GitHub with an open source license, so everybody can benefit from it. And we really feel strongly about it. We put a lot of work into not just the challenge, but also the evaluation methodology, cleaning the dataset, a Kaggle notebook, 4 baselines. The more the merrier. Just a tons of material that, irrespective of this challenge, can be reused in the future to reproduce these results and kind of like move the field forward. And finally, we want to maximize real-world impact. So all the artifacts are reusable thanks to RecList, and you can use them in your next project or in your next paper. And of course, we kind of like ask people to build recommender system that use a reasonable amount of compute. Of course, reasonable amount of compute means different things for very different people. But in our case, we kind of have models that that any company or even a small university can actually train, which is great. So EvalRS was brought to you with love by a combination of people from industry, South Park Commons, Coveo, Microsoft, and NVIDIA, and academia, Stanford University, Bocconi, and NYU. Most of the people have been chosen because they're very good looking and somewhat mildly competent. As you can see here for the picture, Patrick needs to grow a beard because he's the only one that doesn't have it in the organizing team. I know it doesn't show, maybe it shows, but organizing a data challenge is an outrageous amount of work. It's good work, and we had fun doing it. We're not complaining, but really thank you for all the people in the team for all the work that they put into, and to guarantee somehow that this was like a successful challenge. So I'm gonna propose a round of applause for us. And thanks to all my teammates for the extraordinary work that we did. So the challenge was pretty successful. So we have more than 100 participants. Our rough count is like 60% from industry and 40% from academia. More than 14 countries, more than people from 14 countries based on the affiliation took part in the challenge. And the cool thing, I think, to us is that the challenge is not just a tech challenge. Recommender system is one of the most important ML system in the world, one of the most impactful if you think of your everyday life. And so we're super happy to have tech companies of all sizes, from Coveo to NVIDIA, but also traditional company like Fidelity or MasterCard that actually try and kind of get better at this problem. So at the end, 50 teams were formed, and we received more than 700 total submission in people trying to actually win the leaderboard. Of course, sorry for the marketing slides, but yeah, EvalRS is possible. EvalRS is born of a combination of our previous paper and popular open source project RecList, and Tobias' idea from Microsoft that we should organize a data challenge based on this. So the way EvalRS is possible, thanks to kind of like merging this kind of like thread of thoughts. And of course, all the awards and all the prizes are possible thanks to the sponsors of our open source project. So Comet, Neptune, and Gantry. They're a very forward-looking company in MLOps space, and we just don't want to thank them for supporting us. But please, if you get some time, go and check out what they're doing on their website. They're an amazing company, and we really thank them for the support of open source. And of course, if you want to support our own effort, if you haven't done already, we always ask just one thing: go on GitHub, add a star to our repo, so that it can help spread the word of how important is testing for recommender system. We have two fantastic speakers today. One, Professor Dietmar is, opened up this session with a fantastic talk, and we're gonna have Prof. Michael Extern at the end closing the session. Unfortunately, for unforeseeable reason, Michael couldn't travel with us, so he's not gonna be with us in person as it was originally scheduled, but he's still gonna do the talk remotely. So if you're following here, please stay until the end. We're gonna talk about fairness in recommender system, which is another super important topic that the challenge touch upon. What did we do? I mean, I see some people here that spend months on this challenge, so you can totally sleep during this session. EvalRS is basically a song recommender challenge, like a good old user item recommendation. But we ask people to not just model that are accurate according to some, ranking measure, let's say MRR, but also fair and robust. What does it mean fair? Well, fair generally means that, if we want their model to perform somewhat stable, in a stable way across different subgroups, right? For example, if your model is suggesting songs to user in Japan or in US, we want the model to be somehow, almost equally accurate in these two cases, and not, for example, being very good at US just because the vast majority of the users are there. And of course, we want the model to be robust, which means that, for example, when a recommendation is wrong, we want to make sure that it's kind of still reasonably wrong, right? One thing that I think we touched upon, was touched on before in the keynote, is this idea that, they're not all type of mistakes are the same. And so I think a huge also contribution, both in terms of coding and in terms of idea of RecList, is using latent spaces to somehow hack the process of defining, semantic similarity for this type of problem. If you look at these two charts, which are real charts from our challenge, you can see here, and immediately, these are two fairness metrics, gender and country. And we plot here MRR, so the accuracy for ranking, versus a measure of fairness across different genders and different countries. And you can see here, it's not super easy to be good at both. As most models are either good at one or the other, and a lot of models are actually terrible at both in the first picture. So we have three types of metrics that we operationalize. We invite you to go and look at the paper and the repo. Again, it's all open source. You can do whatever you want with it. But just to give a sense, so one is the standard information retrieval metrics, MRR and DCG, blah, blah, blah. One is the same type of metric, but divided by importance slices. So for example, again, comparing the MRR on different genders and see how model fares. And finally, behavioral metrics, which, it's kind of this idea that we want to enforce certain type of properties on our suggestions, for example, robustness, but also diversity and so on and so forth. And again, if we have to sum up the challenge in one sentence, it turns out that it's pretty hard. It's really, really hard. When you move from a one-dimensional accuracy target to a multi-dimensional, it's very, very hard. The dataset is a cleanup version of the last FM dataset. Thanks so much, Patrick and Giuseppe, for the outstanding work here. And at the end, is a reasonably sized dataset, right? So it's like 100,000 user, 800,000 tracks, and 38 million listening event. If you look at the distribution of user and artist, you find immediately that the power law there, if your eye is trained to power laws, you find immediately that this may be a problem for a recommender system. As recommender system tends, of course, to be very good with the items and user that are very, very frequent, but tends to then be not super good in the tail. And even just those two charts are kind of a motivation in themselves to kind of like have this challenge. We had two problems that we need to figure out. One is, well, the dataset is public, so we can just hide a part of the test set because people will overfit to the missing part because everybody can download the dataset. And the challenge two is, which is an open problem, and thanks Dietmar for pointing it out. Since we have different type of metrics, how do we combine them to a final score? Very important thing. We really not the leaderboard type. So as in, there's an argument to be made that you can even avoid combining the scores and have a qualitative assessment of the different strength to this, but we need to assign prizes. So at some point we need to come up with a way to, somehow order them in a deterministic way, which may or may not be correct, but we had to do it and we did our best. So to solve the first challenge, we borrow a page from Tobias' playbook on nested bootstrap validation. So what happens is that you actually download the entire website, the entire data set, and then you repeat the process n times of like randomly splitting between user, the train set and test set, and then you kind of average out your metrics across these folds. We use 4 folds for the challenge. And the second challenge, since we have no idea a priori how models and how participant will actually do this challenge, what we did, we divided the challenge into phases. Phase 1, people were able to submit whatever they want with no repercussion in the leaderboard. And then we use the metrics of individual tests in phase 1 to calibrate a weighted score for phase 2. And then people were allowed to resubmit again for phase 2, and the result of phase 2 are what determines the actual winner. Again, may not be perfect, but it was the best thing we could do. Now that the boring part is done, everybody thinks that everybody's been waiting for. So I'm super happy on behalf of everybody in the organizing committee to award the winners of all our prizes. So we're gonna go category by category, and just go around. So the first awards is the Students Awards, which are generally offered by Coveo, and these are the people that won. I'm gonna try and pronounce their name. I'm gonna probably make terrible mistakes, but please know that I'm trying to do this in good faith. So Wei Du, which is here, cool. Flavio no, I'm kidding. I know how to read this. Flavio Giuvergia, Wei Yao Wang, Jinyo Park, and Dain Kim. So thanks so much. You're our favorite students for this challenge, and we really congratulate you for your success. So Leaderboards Awards. The Leaderboards Awards are, well, it's very self-explanatory. We award the first 2 teams in this challenge. They win a monetary prize. The winning team at the end of the day, with a combined score of 1.7, which totally doesn't mean anything because it's an arbitrary scale, is the league team, which unfortunately they cannot be with us for time zone reasons, but congratulations to them. And the second position is the ML team, with Jinyon Park, Dan Kim, and Dongwo Kim, which are going to give a talk just later today. So congratulations again for the winners. Finally, we have 2 special awards. One is Best Paper, which also with monetary prizes. One is Best Paper, and the one is Best Test, since everybody was encouraged to contribute to the testing library they were building. So the Best Paper award goes to Item-Based Variational Autoencoder for Fair Music Recommendation by Jinyo Park, Dan Kim, and Dongwoo Kim. And I'm gonna read the committee comment that justify the award. The paper is solid, well argued, and reports interesting findings that lead to fairer recommender system and are valuable for the community. The authors also captured the spirit of this data challenge, proposing an interesting addition to the RecList suite with a new evaluation metric for fairness, which does point out real shortcomings of the evaluation method shows for EvalRS, which means that we're basically awarding people that say they were wrong, which I think is amazing. So congratulations for the best paper. Thanks so much. And finally, last award. The Best Test Award goes to the Variance Agreement Test by Flavio. And the committee says that we evaluated each team's proposed test under the criteria of originality, relevance, and code quality. And we believe the best test is the Variance Agreement from Team Flavio. Flavio is going to have a talk later on, so we're going to listen directly from his own voice about this test. Congratulations, Flavio, again.
Thank you.
So last slide. So what are we going next? What did we learn by running EvalRS with all of you? Well, building recommender system is very hard. Each one of you puts a lot of time into this. Again, thanks so much for our participant. We got fantastic submission and fantastic code that we can now evaluate. But it turns out that even the best submission still struggle according to some dimension of the one that we actually spell out as important. So there's still a ton of work to do. And the second thing that we learned, well, we kind of figured it out before, but the second thing that we, let's say, relearned is that evaluating random system is even harder. Like even when we all agree, we sit down here, you know, we listen to Dietmar, we listen to Michael, we listen to me, and we all agree that random evaluation is better than just accuracy, and that we need to do better at this. A whole new kind of problem actually opens up. As even, you know, harmonizing different type of tests or different type of criteria is still very hard. It's very hard to do it, especially without, you know, without a determined use case in mind. It's very hard just to make a principled decision that apply across different scenarios instead of just, you know, go looking at specificity of your data set over your problem. So what we're gonna do next? Of course, we're gonna wrap up this workshop and challenge, and we're gonna disseminate the artifacts, like all the code, all the models, all the tests in the community. If you want to be part of this, don't ask what RecList can do for you, but of course, you know, ask what you can do for RecList. If you want to be part of our library, it's all open source, MIT license for the community. Please reach out. We're super happy to have people helping us out. And philosophically, well, our biggest open thread of thoughts is about trading off different tests, which again, it was a problem that was featured prominently in our first keynote. Can we make it less so? Can we make it less arbitrary? So we're gonna build upon the hundreds of submissions that we actually received and find out if different ways of weighting this test or different ways of evaluating the system would have actually produced a different leaderboard, or which insight we can gain from this. Because at the end, we actually generate fairly interesting data by running this challenge, and we look forward to leverage that to share with the community new ideas and new topics on that. That's it. If you want to contribute to our open source project, you know, go on GitHub, send us an email. We're super happy to have you. And generally speaking, thanks again to everybody, the organizer, the people here, Surya, and all the people from CIKM that made this possible, all the people that join us in person, all the people that join us online, and everybody that participated in this to make a fantastic data challenge. We're super proud and happy to have been able to organize this with you. So thank you again.